Hello, welcome to Math for All, where we try to make math creative, curious, and inclusive for everyone. I'm Molly Vokey.
And I'm Heidi Subnani. Thank you so much for joining us tonight. We are really excited about our guest this evening, and I know that you'll get a lot out of our conversation with her. But if you would like to follow along on Twitter or X or Blue Sky or Math for All on YouTube or Facebook, you can do that. And then you will always know when we have a new guest and a new awesome free way to get some professional development from amazing educators in the field. So give us a like.
Yes. Yeah. And we're super excited about our guest today because we're going to be talking about manipulatives. And we love those. Well, I guess I gave away some of the questions.
That's
So,
okay.
all right. Well, that's okay. She's going to do a much better job than I am. So, how do we really help our students make meaningful mathematical connections? So, we are going to be talking to Dr. Kim Rimbey today, and I am going to introduce her. Kim is an educational entrepreneur, author, inventor, mentor, math coach, and above all else, a teacher. Whether working at the school, district, or state level, she has never forgotten the realities of classroom teaching. Kim is the co-inventor of KP 10-frame tiles, the author of 3 books published by Corwin, and an official Building Thinking Classrooms team member and facilitator. The book
I can only hold up 2 at a time.
So let's bring her in. I almost said good morning, which it is not. It is not morning where we are. So,
me either.
Yeah. Well, we are delighted to have you here today, and we're super excited about your topic. We got to have a chat with her early this week, so we have a preview of what we're going to talk about, and it's exciting.
But we always love to start with what is your math story. So if people don't know you and your work, they can get to know you a little bit better. How did you get to where you are now?
Oh, my math story. I feel like I have to go all the way back to childhood.
Which is totally okay.
As a kid, math was always, I want to say it was my gig in that I was fast and I was a good memorizer. And so I was known for being good at math, and I always felt like I was good at math. But I knew that something was missing, right? But I was good enough to make it through all of my grade school classes, my high school classes. I landed in college. I started with credits already in math because of my ACT scores. And I took set theory, finite mathematics, 3 semesters of calculus. And oh, by the way, only one of 2 girls out of 50 people who took the calculus series, right?
Yikes.
So yeah, I just did it because I could, right? It wasn't something I was passionate about, not something I loved. But let me tell you, when I was getting my undergrad, by far, the hardest math class I took was math methods. I was getting both a math degree and an elementary education degree. And math methods was so hard because we had this amazing professor who pushed us to really experience what it's like to understand math conceptually. And that's when I realized what was missing for me. I didn't really understand the profound ideas of place value. I didn't really get the profound ideas of fraction equivalence and the equal sign, meaning that both sides have the same amount as opposed to finding the answer. There was something intuitive that worked for me, but I was fascinated with this whole idea of understanding math conceptually. And I ended up with all that math coursework, getting out of college and teaching kindergarten because I loved cognitive psychology. And with those little kids, you could see their math development and how they were learning and how they were making sense of things. So I thought I was going to teach kindergarten for the rest of my life because I loved the world of kindergarten and I loved watching young kids learn. And then I actually was more of a literacy specialist at first, but after I thought I was going to teach kindergarten for the rest of my life, but then I just had through a series of circumstances, I had a chance to go work for a principal I really wanted to work for. And I only had first grade opening. So I decided I'm going to go teach first grade. And I get into the first grade classroom and I found out I loved teaching first grade because those kids, they already knew how to hold pencils. They already knew how to cut with scissors. They already had basic reading foundations. But what really got my attention was this developmental jump that happened when all of a sudden they could understand or they could socially play games. And they weren't always trying to cheat in order to win. And the world of math games. Oh, I mean, I was a Marilyn Burns fan. I was following Constance Camille. Everything was all about the math games. And I thought I was going to teach first grade for the rest of my life until a neighboring school district had a brand new position open up called math specialist. And I didn't even know what it was. I just thought, you know what? I have this math degree. Maybe I could use it. So I jumped over and I thought I can do anything for a year. So I jumped over and I took the math specialist job, which ended up being a math coaching job, but we didn't know that at first. And I found out I loved being a math specialist. I loved working with teachers. And I was the kind of math specialist who was like in classrooms all day, every day, co-teaching with teachers, just becoming a better math teacher while I was supporting teachers with their math instruction. And so now all of a sudden, I have to tell you, I was shaking in my boots the first time I walked into a fifth grade classroom. That was my first assignment. I'd never taught anything above first grade. And so I go into the first grade or the fifth grade classroom and you know what I found out within 5 minutes? Fifth graders, not all that different from 5-year-olds, right?
Totally.
Yeah. So I spent 11 years developing what would now be called math coaching. Back then, there wasn't really that kind of thing. But loved teaching, being a math coach. I thought I was going to do it for the rest of my life.
I was going to say that.
There was this nonprofit called the Rodell Foundation of Arizona that was looking for a math specialist who could do statewide professional development. And I thought, I can do anything for a year. So I hop over to the nonprofit.
And then you're going to do it for the rest of your life.
And yes, I loved it. I loved, because you know what happens when you go from the classroom to working with the whole school, your perspective changes. When you go from a school to working with the whole district, when you go from a district to working with multiple districts, your perspective changes. And it was kind of in this time that my collective started becoming a really important idea to me. Because you know what, these things as a math specialist, they weren't working for me. Because every time the kids traded for like 10 ones for a 10, they would like miscount, right?
Yeah.
So anyway, that's when I started doing math professional development. I ended up taking a little break from that when that shut down after 10 years.
Wow.
I had a stint as a curriculum director, but no matter what leadership position I took, I always wanted to make sure I never forgot what classroom teaching was all about. And that was something that I was known for. I was the leader who came into classrooms and we played math together regularly. And so that's kind of my math story is, I kind of came backwards into like I was good at math, but I didn't really get it until I was pushed by a professor to understand conceptually. And that completely shaped my work as a teacher.
I feel like that almost seems really early compared to lots of people's stories to be diving into conceptual understanding, which how lucky for you, because I have a similar-ish story where I went to, was good at math, maybe not as good as you, because I didn't want to take all those calculus courses, but I did take calculus. But and when I got to college, I did take the math methods course, but it was a lot of like cooperative learning, and it wasn't deep conceptual understanding. And it wasn't until I had to start teaching myself that I was like, oh, kids are asking me questions, I don't know the answers. I'm gonna have to start learning more. I thought I knew things, I don't. So I find that fascinating that you had this amazing professor that really helped you to dig deep, because it seems kind of rare, actually.
Even now, new teachers that I support, and they have limited experience with using manipulatives in their elementary math methods courses, or very, maybe one course in, in like one area, you know, and you come in with an elementary certification and you're supposed to go from not having one-to-one correspondence to all the way up through, you know,
Right?
fifth grade content, which is significant. So, you know, when we think about that was really an awesome opportunity that you had, and think about where you might have been if that hadn't been
Oh, yeah.
your experience.
I mean, what do they say? It takes 10,000 hours to really develop expertise in
Mhm.
something. And as an elementary teacher, we don't get to spend a lot of time on any one content. So for me,
Mhm.
spending 11 years developing myself as a math teacher, right? And really understanding across kindergarten through sixth grade what it takes to understand conceptually. And then honestly, later on, advancing that into middle school and into high school.
Mhm.
Um, but it all starts in kindergarten,
Yeah.
right? Everything we
does,
need to
and
know, we learn in kindergarten.
right. And what a unique opportunity also to be able to see the whole spectrum when you are the math specialist coach,
Mhm.
which, you know, are fairly prevalent now, but I know what you're talking about. Then that wasn't a thing. Lots of reading specialists, but not really for math. And um, it is, I mean, Heidi can attest, right? Like when you first started doing this job in math, because you had
Mhm.
done this job in English beforehand, you know, being able to look at all the trajectories,
Mhm.
and there are many of them in math. It's not just like this one, right? And look at them spanning across grades. It's actually pretty fascinating to see the development, and conceptually, if you're not looking at it conceptually, then it's pretty boring,
Mhm.
Agreed.
I think.
So true. Well,
Well,
that
I mean, that leads us right into our question, right? So how do we really help our students make meaningful mathematical connections?
Yeah, that's a great question.
I
And so,
know.
right? And I think there's been a lot that's come out most recently that really spotlights what research says
Mhm.
about how to help kids make these meaningful connections. And have you heard of the Lesh diagram?
Yes.
Yes, I mean it's in a lot of the books that we as teachers buy now, but it's really this diagram that looks like a star, right?
Mhm.
And so we want our kids to be able to represent their thinking, right? So this is the translation model between representations. But really, here's what happens is mathematical thinking is primarily a mental activity, right?
Mhm.
It happens behind the eyes. We can't really see
Mhm.
what our kids do and don't understand. And so we're really dependent on them representing their thinking, whether they're verbalizing it or they're showing us with some
Yeah.
kind of object, right? So we're really dependent on that representation model. So that's what the Lesh diagram really helps me hone in on what are the different ways that kids can help me understand what they're thinking to make connections to all the different math ideas that we're trying to help
Mhm.
them understand. So the Lesh diagram is one way that we can help ourselves see that. And the first thing starts with those physical tools,
Mhm.
right? The manipulatives.
Yep.
And that's one of the reasons I'm really fascinated by using physical tools, whether it's base 10 blocks or algebra tiles or two color counters or any of the different kinds of fraction pieces, the base 10 pieces. Kids, when they can use something physical, they can show us their thinking.
Mhm.
And the physical tools, they can help the kids either communicate their thinking or sometimes it facilitates their thinking. Like
Mhm.
maybe they're not quite there yet, and those
Yeah.
tools actually help them make the jump. So you have the physical tools, but then you also have the visual tools. And the visual tools would be the number lines and the number bonds, the coordinate grid, anything that's visual, that's paper pencil.
Mhm.
I would also put virtual
Virtual,
manipulation
yeah, I was gonna say.
category,
Yeah.
right? Even though you can manipulate them, you can still
Yeah.
move them. They're not physical objects. They're not
Right.
3D, right? And the
Mhm.
brain processes three-dimensional objects differently than
Mhm.
two-dimensional. So those are our visual tools. And then we have the symbolic tools, right? These are our numerals and our equality symbols and our operation symbols, just the symbolic world that math lives in.
Mhm.
Mhm.
Then we have the verbal tools. This is either speaking or writing, but just any way that kids can communicate their
Mhm.
thinking. And then last of all, we have the contextual tools. How do the kids make those connections with real life? And one of my favorite things to do with the contextual is not to just give them word problems, because those are often kind of boring. They're contrived.
Mhm.
So I often like to say to the kids, okay, guys, 95 divided by 4. What could this expression be describing?
Mhm.
And I have them tell me what it could be describing. Like that could be 95 soccer balls shared evenly put
Mhm.
evenly into 4 bins. Or one of my 4th graders said, oh, that's 95 hair ribbons shared among 4 sisters evenly. Or one of them even said, that's 95 carrots put into 4 buckets in the cafeteria evenly.
Yeah.
I thought, well, that's kind of odd for a 4th grader to come up with, but it came from them, right?
Yeah.
So I want them to assign context, right? So they're making connections that way.
Mhm.
But here's the important thing about the Lesh model is that it's not just about the kids doing these 5 different things. It's about them making connections between them. So like physical tools and visual tools. I want kids to be able to take manipulatives, but also be able to represent them using some kind of a diagram. It can be I might have kids do side-by-side math. Like I wrote a blog post on it for Corwin called Side-by-Side Math, where the kids might, you have one child using physical objects, manipulatives, and another child who has maybe a whiteboard. And together at the same time, they're coordinating their efforts and talking about how they're representing the same thing. So then they're making those connections from what's happening with the physical tools to the visual tools. Or we want the kids to be able to connect the visual with the symbolic. So maybe we have that again, that can be side by side, where one child is sketching and another child is actually doing writing the symbols. Or we can have the kids connecting symbolic and verbal, or verbal and contextual. So these all need to be connected to one another across the entire diagram, right? So that's what we want to do to help them make those connections. What are you thinking so far?
Yeah.
I mean, it's a lot of the work that we do. So we are 100% cheerleaders of all of this. And I think it's a hard jump for some teachers who learned the traditional way of memorization and mimicking, to, especially as you go up in grades, to have them doing some exploration with manipulatives that they are unfamiliar with. You know, I was working with some teachers a couple months ago, and it was middle school teachers, and we were doing fraction stuff, and I just wanted them to experience some of the manipulatives, even though it wasn't necessarily their content area. And one teacher said to me, so what would I do with this?
Right?
I was like, okay.
That's the right question. But that's a fair question, right?
It is. It is.
Yeah.
It
so
is.
That's in my work with teachers. That's something that I think we really do have to focus in on. I mean, there are some really fair objections to using manipulatives in our classrooms, right?
Oh,
and one of them is, I don't think about math that way. I don't know how to teach math that way. So let me tell you a story. You mentioned earlier, I'm the co-inventor of KP 10 frame tiles.
Yes.
So
we love these.
that's one thing I found is that I mentioned a moment ago, base 10 blocks have been around for 100 years. They were designed in the 1920s. And I always found them a little bit problematic, because every time the kids do these trades, they'd kind of get lost, right, with those trades. And they might trade for 9 ones or 11 ones. But the truth is, that's not how the number system works. The number system actually works with our kids counting. Like they actually have 10 objects. So here I have just a 10 frame, just a clear little 10 frame. We use these in kindergarten and first grade, right? So this is a clear 10 frame. And the kids can snap these little tiles right onto the 10 frame. Hear that snap? And then they can have that 10, and I'm not going to trade for anything. Those 10 things are going to literally become one group of 10. And it's still 10 ones, but it's
see the individuals.
Right? So helping kids make those connections. And those are our kindergarten and first grade standards, going from 10 ones to one group of 10. Right? But then we can go a step further, and we have a large 10 frame where we can collect these groups of 10, right? So we collect those all the way up to 100. And then we can cover that up into one group of 100. And I asked the kids, I was just in a 4th grade classroom yesterday, and I said, okay, so what is this? 100 whats? And they said, 100 tens. So, okay, let's kind of about that again. How many tens were inside there?
Yep.
Oh, and it took them a little while to realize, oh, we're talking about 100 ones. We're naming how many units are inside there.
Yep.
Where is your 1,000?
Right?
Yeah.
So
How big is your 1,000?
right, it's 10 of these. And honestly, the screen right here is a little bit too small. But we can build those out to have 5 rows or 2 rows of 5 to get to 1,000. And we just put a piece of butcher paper to have one group of 1,000. But here's a 5th grade story. 4th and 5th graders, we get to this point. We've built this all the way up. And we start counting 100, 200, 300, 400, 500, all the way up to 800, 900, 1,000. Half the kids say 1,000, half the kids say 1,000. And I say, okay, guys, which is it? 1,000 or 1,000? You want to hear a really great debate. Ask that question to 4th graders who haven't fully grasped the nesting nature of place value. It's a great debate. And we finally come to the conclusion. They come to the conclusion that, oh, it's both. We can call it 1,000, but its real name is 1,000, but it is 1,000 and it's called 1,000. And that's something we skipped over in the younger grades, right? We skipped over this idea that 10 ones is a group of 10. And it's still 10 ones. And it is a group of 10. And this manipulative kind of got in the way of understanding that. Because here we traded 10 ones for 110, or we traded 10 rods for a flat. So, but here, now that was a really long intro just because I wanted to make sure everyone knows what's going on with this manipulative. So here's 5th story. I was working with 5th grade teachers a while back. And with the 5th grade teachers, we were actually working on decimal operations, right? So we took this and we talked about how this is one group of 10. I mean, I'm sorry, this is one whole. We just got through our fraction sheet. This is one whole. And inside you can see that it's broken up into 10 tenths and 100 hundredths. So let me ask you this. If we were to work on this together, can you tell me why is 6 tenths divided by 2 tenths? Can you tell me why? And the teachers are like, I'm not sure I can. So we worked right with this manipulative. And we said, okay, if that was a whole, then what is this? Oh, yeah, this is 6 tenths. And we want to know how many 2 tenths are there in 6 tenths, right? So here's 2 tenths. Here's 2 tenths. Here's 2 tenths. So we can see that we end up with 3 groups that each have 2 tenths. And the teachers were like, oh, let's do that again. So we did it again.
It's kind of amazing how I mean, I have not used this manipulative, but obviously I'm dying to use it. But even if you're using fraction bars, which aren't going to show the tenths quite the same way as what you have there, but I find when you change a division question into how many of this fit into this, it just illuminates division.
Yes.
In a way that automatically triggers the brain to change its idea of what they were thinking before that question was asked. It's like magic.
We're really talking about 2 things here, right? We're talking about number 1, using the language in a way that helps or illuminate what's going on with the math, right? So asking those questions, and honestly, what you just said, asking the right question, that is the question that we asked back in 3rd grade. Back in 3rd grade, when we were looking at 12 divided by 3, we would say, how many groups are there in 12? So we need to be using that same language as we get up into higher grades with more complex arithmetic, but that language matters. And then making it visible.
Yeah.
Right. But even as it is for the teachers, we did this once, we did it twice. They wanted to do it one more time. And then I said, okay, guys, now it's your turn. And I handed them all this tool to try it out themselves. One of the teachers looks up at me and she says, oh, Kim, this was so much easier when you were doing it. Right. And that speaks
so true.
Yeah.
Yeah, that speaks to we as teachers, we all know we're supposed to use manipulatives. We all know that it's really good for kids to have hands-on experiences. But we have to be given the grace and the time to figure out the math of manipulatives for ourselves. I talk with teachers all the time about, you need to practice the pedagogical language before you get in front of kids. Because there's a good chance that because you haven't played with this is easy for me because I use this tool all the time, but you have to practice, right? And then I'll say, you know what, this is a really good tool for, like, if you haven't been using manipulatives, then I'll say, you know what, just in the beginning, rather than trying to put this in everyone's hands, just use it to model your thinking with your kids for your think alouds, right? So let them see you do a think aloud with this tool. And then try it in small groups. You're still practicing how you're talking about this, right? So just try it with a small group of kids. And then eventually you'll get comfortable with doing it with your whole class. So we as teachers have to give ourselves the space to learn how to do this.
I love that idea of like using it to model your own thinking. And or one thing I tried not too long ago in a first grade class, they were using, it's not a rec and rec because it was 100, but the same idea as a 100 rec and rec. I don't know. And this was the tool that they had enough of. And then it was a first grade class and they were working on it. And as kids were talking, I started modeling on the teacher one up front what the kids were doing and saying. And like all of a sudden you can see all the teachers in the back, like furiously like, oh, this is what, I was like, I can't expect them to use a tool if I'm not showing them like in real time how like you can do that to like record student thinking, because we want to try and record it both conceptually for the other students and like record it in number or number line as well, so it's like that multiple modes that we're trying to provide for teachers and students. And I feel like sometimes like number talks or activators, those are like entry points that can be a little more accessible to, like, we're just going to try one representation for a little while and think about it from that way. But I love the subitizing nature of your particular tool, because I feel that like sometimes it's really hard to, yes, you can see that it's one rod of 10 if you're using base 10 blocks, but if you have individual pieces and you haven't lined them up in a 10 frame form, which is usually, if I'm working with, like, that's how we think about organ. I can't tell necessarily that it's 6 or 7 if it's in a straight line and there's space in between, but I can, if it's in a 10 frame form, I'm seeing those pieces because of the fluency that we're hopefully building with kids at younger grade levels with that tool that then translates to something bigger.
Yeah. Well, and we have our place value chips, right?
Yep.
Another manipulative that we use. And often I find it's really helpful for kids to even be doing this side by side to see the connection between a tool that nests and a tool that doesn't. Right.
I love that.
I'll have kids working side by side and they're negotiating the language of math as they're doing this, but they're seeing how, okay, this is an abstraction. Right.
Yes. It's just like the number that you don't have to write. It's not
right.
It's not sized any differently. It's not,
Yep. So,
right. But what's great about that, what is the side by side that you were just talking about, is like, if they're going to be using this for like bigger numbers when place value, when they're practicing regrouping and all of that stuff, it's harder to use the nesting one. Like if they use the nesting one to build that conceptual understanding so that they can use that disc later on, that's the key. And I think sometimes teachers don't I have another question too that I've been waiting to ask, but sometimes I think that teachers don't understand, like, we don't expect kids to use manipulatives forever. Like, manipulatives are a tool for understanding the concept so they can move on to exactly,
Which is
so
why
they
we
can
need those
move on to the symbolic.
Yeah.
And other teachers will argue, well, they're not allowed to use that on, in our case, it would be MCAS, state testing, or blah, blah, blah. So I shouldn't let them use it. I'm like, but you're not seeing the point of it is to build understanding so the symbolic will be accessible to them. I don't know. It's a hard sell for some teachers, and I think like your whole point of having them play is leading to my next question. But in my experience, I'm not going to start with that. Have you experienced, if teachers are willing to play and have some success with one manipulative, do you find that translates to them wanting to use other manipulatives? Or do they still need to have a great amount of time to adjust to a new manipulative?
Well, I think that it's related, right? I think that just as with our kids, they need a chance to explore the properties of the manipulative to figure out how does this reveal the math? How can I use this to communicate my thinking or facilitate my thinking? An example would be using pattern blocks to help kids understand fractions. Right. I use these as fraction pieces as well as things like, fraction bars and fraction circles. So what I have found is once we start using manipulatives and we as teachers start seeing the profundity of making math visible for our kids, the transfer to other tools is much quicker. But it still takes a beat to figure out, okay, what are the properties of this new tool and how do I use it to communicate or facilitate my thinking, right? And how am I going to help kids use it to communicate their thinking?
Well, and I love that idea of like how we're using that tool to help facilitate their math thinking, because I was having this conversation with one of my 5th grade teachers who I've worked with for quite a while and in this district. And I was teaching a manipulative course. And they can just sign up for whatever manipulative or series of. And so she had come to work on Cuisinart rods because she's like, I don't know enough. And I feel like so she came in and we were like deep dive right into all things Cuisinart rods. And I then went in her class and worked with a small group with them and all that. And then we were having the conversation around, well, do I use these or do I use fraction tiles? Do I use this or like if I'm going to pick one, which one should I pick? And then I was like, well, do we have to pick one? Like, and I was thinking in my head, and she's like, well, but if I'm going to take the time, like if I want to get them, and I was like, but one tool may not work for everybody in the same way, right? Like sometimes pattern blocks work really well for me, and other times if I'm like in my early understanding and development of like pattern blocks made more sense to me as a learner, but for other people maybe not. But if I'm trying to transfer from like to a number line at some point, like I may want to use a fraction bar or a Cuisinart rod where I can see those partitions or iterate in ways a little bit more clearly. And so but it's that, like, how do you make the case? give me another tool. How do you make the case for like multiple tools?
Yeah, Heidi, I think, and Kim answered this after me, but like I think that sometimes the activity can help dictate what the tool is, because like as soon as you mentioned pattern blocks, like I thought of a specific activity that I've used several times with teachers and with students that has been profoundly successful. And it didn't matter who you were or what you believed. This activity helped you to understand that the whole can change, right? Like the whole is not always the same, right? So I'm dying to hear what Kim is going to say to your question, but I definitely think that sometimes it's the activity itself that can help choose what the manipulatives.
So yeah, Molly, I agree with you wholeheartedly. And that is one of my favorite fraction activities with pattern blocks as well, is the whole can change.
Yes. And Cuisinart rods and like
either
or like for those two. And I'm like, that's one of the reasons I use that.
I
Yeah.
love, and you know what, Cuisinart rods, I think, are kind of making a comeback. They disappeared
Yeah.
for a while, right? I mean, they were really popular in the 60s,
Mhm.
right? Before any of us was doing this work
Yeah.
yet. And they're making a comeback. But here's to speak to your question, I think it's really important for us to keep in mind the mathematical practice number 5.
Yeah.
You know, a lot of our state standards frameworks are still focusing on the mathematical practices or some version of them. Right? So mathematical practice number 5 says we want our kids to be able to choose appropriate tools strategically
Mhm.
and use them strategically,
Mhm.
right?
Yeah.
And so there's choice in there that we're
Mhm.
supposed to be giving to our students, which means that we as teachers have to pave the way for that choice to happen.
Mhm.
Which means that we want to make sure that they've been exposed to Cuisinart rods as fraction models and pattern blocks as fraction models and fraction bars and fraction circles. And then, like Molly was saying, a lot of times, sometimes it's the activity that kind of pushes you towards one particular tool. Sometimes it's a preference because you just understand that tool better and the properties of it.
Mhm.
And so I think for the teacher who was asking that question, I think you're right, Heidi. We don't have to choose. And in fact, there's a really good reasons for us to not choose,
Mhm.
for us to not tell the kids, okay, today everyone's going to use Cuisinart rods. Then we
Right.
put them away. And today everyone's going to use pattern blocks.
Yep.
Right. And one of my favorite things to do, this is in my management blog post that I wrote for Corwin a few months ago. But at the beginning of the year, I have those plastic shoe boxes that you get from Target or Walmart. And that have the lids on, the snap lids, you know.
Mhm.
And at the beginning of the year, I just introduced one manipulative at a time.
Mhm.
So maybe the second week of school, we're going to be using square color tiles.
Mhm.
So for that particular activity, we are going to learn how to use square color tiles, and I'm going to introduce it in a very purposeful way.
Mhm.
Like every tool I share with kids, we talk about how do you use this in a playful way? How do you use this in a purposeful way? We make an anchor chart that
Mhm.
shows what it looks like to be playful versus purposeful.
Mhm.
And in math class, we're going to be purposeful.
Yeah.
You can be playful on when you have fun Friday or on your free time, but we're going to be purposeful. First graders, when we're using these tiles during math class, we're going to use them to show number pairs that add to 10.
Mhm.
So now everyone's tub just has square color tiles in it.
Mhm.
And then maybe in a week or two, we might introduce pattern blocks for an activity.
Mhm.
And now they can choose to use square color tiles or pattern blocks.
Mhm. Okay.
And then comes along another activity where we're going to introduce KP10 frame tiles.
Mhm.
And now that's added to the toolbox in the middle of the table. And now you can choose square color tiles or pattern blocks or KP10 frame tiles. Right. So we just keep adding to this toolbox throughout first quarter. And then for the rest of the year, the kids have had a chance to explore the tools, to understand their properties. And now they can start figuring out which of these tools is most appropriate.
Mhm.
If I'm a second grader and I'm starting to add 2-digit numbers,
Yep.
it's probably not good for me to just be using counters anymore. I probably need to use some kind of a base 10 tool.
Mhm. Mhm.
Right. So helping the kids start to figure out which tools are going to be best for them.
But also, like, how cool is it to think about that and like, are we going to use pattern blocks for this?
Right.
Probably. Yeah. Like it's good for them to be thinking about that.
Mhm.
But I never really thought about having them all personally available to them all the time, just because that seems like a logistical nightmare for teachers. But the way that you just described it doesn't actually sound nightmarish at all.
It's a nightmare if you give them a toolkit that already has 10 manipulatives in it.
Got
On
it.
the first day of
Okay.
school. Good luck.
Clear. Now it's clear.
Yeah, but that's why I just introduce one at a time, and we have this playful versus purposeful conversation with every single tool. So they get that chance to be playful. And I used to do the toys versus tools conversation. A lot of us talk about that with manipulatives. And I steered away from that because I realized that when I said toys, I was like, don't use them as toys. Only use them as tools.
Oh.
And I think
it's not fun.
Needs to be playful.
Yeah.
Right. There's times when I have those multi-snap cubes. Those are just kind of fun. to be playful with. My kids, honestly, I mean, this look, you can see the structure in this.
Yeah.
But they love to build bunk beds and towers and just different designs with this particular tool.
Bunk
Yeah.
beds.
Or pattern blocks. You know, pattern blocks
Yeah.
are so much fun to be playful with.
So fun.
Yeah.
So
I mean, you use them with teachers, you put them out on the table, and I have to give them a good 5 minutes to make something with it because they're going to do it anyway. Like,
Yeah,
so,
even
like,
teachers, yeah.
So we make an anchor chart for each manipulative, playful versus purposeful, and it becomes a management tool later on. So if I have students during math class who start doing something that's more playful in nature, I'll say, oh wait, you know what, guys, we're going to be purposeful with this right now. So what you can be playful on your own time, but let's go back to being purposeful. And so it just helps me keep the kids focused.
I love that.
Me too.
I'm going to make a brief segue. So let's talk about manipulatives and building thinking classroom.
Okay.
Because
that is an excellent segue.
Yeah, sorry, like I'm just let it right out there. Because I've been having this conversation quite a bit about how that way of thinking doesn't mean don't use manipulatives and only have kids stand up, like that it still goes together. So can you talk with us more about that and how the philosophy of building thinking classrooms doesn't mean the manipulatives go bye-bye.
It doesn't. So just, I am like, so like, this is my book. I heard you guys, when you spoke with my friend Amy last month, right? We were all talking about our building thinking classrooms books. And, you know, I actually like my pages are falling out.
Oh my gosh. I can't get my cover to stop being curly. I have laid other books on top of it and I lift it up and it's still curly.
Yeah. You know what? Somebody told me they took it to a print shop and they had the spine professionally taken off and had it spiral bound. And then they just had like a clear cover put over the top.
Oh my gosh. Heidi is going to be at that place 24 hours a day with all of her books now.
No, Staples will do it for you. But
by the way, Heidi, you and I share that. You can see this is probably maybe 10% of my collection back here.
It's a problem. It continues around the world
for me because anytime I need a book, I just ask.
I just believe if it's books, it's not hoarding.
Yeah, exactly. Well, and then there's you can begin to see the manipulative shelving unit situation.
We're going to get along just fine, my friend.
Yeah.
Really
okay. Manipulatives in a thinking classroom.
Yep.
So with building thinking classrooms, first off, I just have to put a plug out there that Peter's book is coming out in May, and there will be a section in there on manipulatives in a thinking classroom. Right. But so here's how I approach it is I've seen a lot of configurations. I've seen teachers who've invested a lot in magnetic manipulatives and magnetic whiteboards. And I think that's nice, but I think that's completely unnecessary. In fact, I think there's something even more powerful that can be done just to use the tools that you already have. And what I think is really, really good is just to take a desk and push a desk up next to each one of your whiteboards in the room. So when your groups of 3 go out to those boards, the kids can have the tools. And you know me, I've already told you about my toolkits, right? Yep. So they can have their toolkits right there on those desks and they can grab manipulatives and they can be working right here on this flat surface. But that is not very visible yet, right? It's not visible to the whole class yet.
Right.
So something kind of magical happens when they take what they just did down here and transfer it up here onto their whiteboard, right? So this is similar to what I call side-by-side math. But what happens is when they take this thinking and then these are the concrete materials, the physical materials, they have to abstract that into something visual. It might be symbolic. It might be a visual with a number line or even just a picture of what they had down here. It might be something with words, but to speak to something you said a little while ago, Molly, I got really excited and I did this because what I was thinking was we have this objection, this concern that kids don't get to use manipulatives when they take tests. But they do get to use scratch paper.
Yes.
And so if they've had these opportunities to work with the manipulatives and then transfer that understanding up here onto their boards, that can be the equivalent of scratch paper later on in test time. So our kids can have these physical tool opportunities, transfer it into 2 dimensions, and now it becomes visible to everybody in the room. But that's, again, where you're seeing these connections play out.
Yeah.
They had those physical tools that they now either made visual or visible, or they might have used a symbolic or verbal representation, but it's up there for everyone to see in the thinking process. Because we got to face it, again, manipulatives help kids communicate their thinking, and they help facilitate their thinking. These should be all about thinking. I get concerned sometimes when we show kids how to use them and we turn them into algorithms because we expect the kids to do what we just did. And it's, no, these are supposed to help with thinking, not with mimicking. And we can fall into that trap with manipulatives too.
Well, and the trap of like, this is for just some kids who need that, versus thinking about it from the perspective of a task with a manipulative can be a thinking task. We can have a very meaty, in-depth series of tasks, either thin sliced or a big task that is so engaging for kids that they will then make those connections between the two. And I think like seeing it, that it still belongs in that space is really powerful.
100%. And I think one thing that you were talking about with the connections from the manipulatives on up to the whiteboard and some type of symbolic that comes naturally to kids. I mean, I have done exactly what you're talking about in a middle school classroom with some manipulatives. Just pull the desk over, and they naturally do go to write down numbers and do some kind of representation, even if it's just some messy work that they need to see. So if we can help them to, even if we have to give them a little bit of a kickstart on how do we make this a little bit more formal, and that can be part of the conversation that you're talking about between groups, and saying, look at their representation and look at their representation, like how do those two things make sense with each other, and which one is easier to understand, or I actually love that a lot.
Yeah, and I think there's 2 things that we've talked about that I think it's really important to connect them. And going back to, like, if I'm working with my middle school kids with integers and we're using 2 color counters to represent positive and negative integers, it's really important that we've had the conversation about how to be purposeful with these when it comes to integers. So they need to have that experience in their background. But then when this is in their toolkit and it's one thing that they can choose the 2 color counters, they can choose algebra tiles, but they choose something to represent their thinking, and then they get it up here for everyone to see, and they realize, oh, there were different pathways to get here, right? We all made sense of this in a different way. You're right, Molly. What a huge, powerful experience that is for our kids.
Yeah. I even had an experience like this the other day. Heidi and I were at a conference in Connecticut, and it was last period of the day doing building thinking classrooms, and I really was looking around to see what others were doing and looking for connections between what they were doing, what we were doing. And I found it to be powerful as a person who knew the mathematics already, a teacher who has taught that mathematics. And being the doer of mathematics is often a real treat for teachers. So it really is exactly what you were talking about earlier in terms of allowing them to, I don't know what your words were, but basically my translation is play with it so that they can understand what the mathematics is. And I full-heartedly had that experience the other day in terms of building thinking classrooms, and I loved it.
Well, and that kind of takes me full circle back to like my own personal story. That, I did math, and I was a producer of math, and I did well in a lot of different math classes. But it took Dr. Patty Horn, my math methods professor, to say, wait a second, you need to understand the profundity of
Mhm.
the nesting nature of place value, right?
Mhm.
And
Mhm.
all of a sudden, all these
Mhm.
started coming to me because I was able to see what my fellow students were doing who weren't getting math degrees. And I
Mhm.
thought, I need to understand that connection too, right?
Mhm.
So I love that you had that experience. And that's what something that none of us had as kids was
Right.
this thinking classroom process of having thinking,
No.
I'm so sad that I was
Mhm.
34 years into my teaching career before
Mhm.
that book came out.
Mhm.
Yeah, right.
Right? So
Right.
it was what I never knew I always needed in
Mhm.
the inquiry process that I used. And
Mhm.
Peter he illuminated, I think he operationalized inquiry learning for us
Mhm.
and collaborative learning.
Yeah.
I think it brought together so many things that we already know is good teaching, but then
Mhm.
kind of put it in this one structure that
Mhm.
is really changing things when you put it all together. It's
Mhm.
amazing.
And then his research,
His research is
it unveiled just nuances that we didn't know.
Mhm.
Groups of 3 instead of groups of 4.
Yeah.
Who knew?
Yeah.
Right? I was
But
already
it
using
makes so much
We're
sense.
using 4 all the time.
right big whiteboards, group whiteboards, but
Mhm.
not flat, up,
Mhm.
vertical. Who knew? Never
Mhm.
occurred
Yeah.
to me.
Mm,
Yeah.
so awesome.
Yeah. No, I was actually having that question or conversation in high school, and they're like, "Well, we have done some work around principles to action, and we were like beginning to like doubt, well, what's the connection?" And I was thinking, principles to action in many ways is like the philosophical underpinnings of a lot of the work that we do, but building thinking classrooms gives you a roadmap to some of those
Well said.
frameworks, and so you're thinking
Mhm.
about, okay, like what are some ways that I can roll out these pieces in manageable chunks. That's just another way to think about, okay, this is one kind of gateway to that, if that makes sense, in order to make it more accessible to teachers, because we're getting there. They're coming on board.
Yeah.
Yeah. Back to that teacher experience. I just think it's so important for our teachers to get that chance to play,
Mhm.
right? To understand this for ourselves and then figure out how are we going to explain this to kids.
Right.
Mhm.
I think a thinking classroom allows that to happen concurrently,
Mhm.
right? Because I don't have to have all the answers before I put this in the hands of kids. Because
Mhm.
I'm not going to ask them to mimic what I did with these.
Mhm.
I just need them to understand how these can help their thinking and let
Yep.
them go with it.
Yeah.
Mm. It's so true.
Well,
Oh, I love this conversation
I know.
so much.
Me too.
it could go on and on, but we
We could.
want to know if people are wanting to learn more about the work that you are doing. We have a couple things that we're going to pop up here on the screen, but if you want to just talk to us a little bit about how people can find out more about you.
Yeah, I would love to. First off, email me anytime. My email address is really easy. It's my name, kimrimbey@gmail.com.
Okay.
And I love having conversations with my colleagues from anywhere. So I would love that. Also, if you want to know more about the manipulative,
Mhm.
kpmathematics.com is where you can learn more about that. If you want to know more about my books, you held up my manipulative books.
Yes.
And here's my small groups books,
Yes.
which
I have that one back there.
right? So those also are on the Corwin website. So you can get those through Corwin. And building thinking classrooms, just reach out if you want to know more about what I do with Peter Liljedahl. And that whole project is also a really exciting extension of the work that I'm doing right now.
Exciting.
Amazing. And we will put in the chats later on some like direct links. Some have gone out, but we will make sure that those end up in that space as well.
Mhm.
Excellent. Yes. Oh, and Facebook. I check Facebook maybe once a day. I'm not a huge social media person, but Facebook is also Kim Rimbey. Twitter, now called X, right?
Yep. Whatever
Yeah.
we're calling it. Yes.
Kim Rimbey. So I just try to keep it real simple. If you want to find me, just look up my name.
Excellent. Excellent. Well, we so appreciate you being here. We obviously love talking about manipulatives, and we love the work that you're doing.
Thank you.
Well, we will say goodnight for now. And thank you so much again for joining us.
Thanks.
Talk about that
Well,
all day.
we must meet her in person because that
Yes,
was
that's true.
super fun. Super fun. Love it, love it, love it.
We are off for a little bit.
I know we do have a
we
longer
have-
break this time.
We have spring break and all the things happening, but we are going to be speaking with our friend Sue O'Connell at the end of April. So we're really excited about that as well.
Yes, we're the luckiest. We get to talk to the coolest people. Until then, we hope that you make math creative, curious, and inclusive for everyone.